Hi, so this video is for any teenagers who are currently taking multivariable calculus in high school right now and they want to know how to do partial derivatives. Okay, so first off, when we're trying to find partial derivatives, we need to understand what exactly the function is. So the function is usually given in terms of what variables we have. So it might be written as fxy, or it could just be written or f. Okay, so for the first order partial derivatives, we can identify these as finding f, the derivative of x in respect to x, or the derivative of f in respect to y. And if f was, for example, in terms of x, y, and z, this would mean that you would also need to find f of z. So if the question asks you, can you find all of the first order partial derivatives, you would need to find either 2 or 3 of these answers. If you were to find second partials, this means that you would need to take each one of these and you would need to find each of those in respect to the variables that are in the original functions. I would need to find the derivative of f of x in respect to x, and then I would also need to find the same thing but in respect to y. And then you would need to find the derivative of fy with respect to y, and then the same thing but respect to x. And we also know that these two are equal because of Claro's theorem. So that's an important thing to note, which you might be asked to prove in a question. The first thing I'm going to do is I'm going to find f, the derivative with respect to x. So in order to do this, I'm going to identify which terms have the variable x in them. So if I look in the original equation, I can see that it's in both equations right here. So because of that, I'm going to derive the term of x, and I'm just going to hold y as a constant. So in the first term, this means that it's going to be 4x to the power of 3. And in the second term, if I'm just considering y to the power of 3 is just like any number, like 1, this would mean that it would result in 6x y to the power of 3. And this time, I need to figure out which terms have y in them. So the first term doesn't even have y in it, but the second term does. So in this question, that means the first term is a constant because it has x. So if I were to derive a constant, it would be 0. So I could just say that that's 0. I'm not going to write it, but we know that. And with this question, we have negative 3x squared, and then we also have to derive 3y squared. So this would result in this being your answer. So the next thing I'm going to do is I'm going to find all my second partial derivatives. So in order to find fxx, I need to figure out which terms within this answer have x in them. So I know that both of them do, so I'm going to find 12x squared minus 6y cubed. So for fyy, again, it has only one term and it has y in it, so we are going to derive this. So we get negative 18x squared y. Again, we're holding the x constant, so x squared just stays the same. We don't need to derive that. It doesn't become 2x, but the y squared will become 2y. And finally, for fxy, that's also equal to fyx, so you can choose which one you want to do. You can choose whether you want to derive from the first one or the second one. I think it's fairly straightforward. No matter what you do, you're only deriving from one term. So I'm just going to do it from fxy. So in the first one, if we're taking with respect to y, the first term doesn't even have y. So I see that it has negative 6. I'm going to multiply that by 3 because that's what's above. It's y cubed. So the answer is negative 18x xy squared. So if I were to also find fyx and use this one instead, this would also be negative 18xy squared because it's x squared. So when you take that down, it's still going to be the same answer. So overall, I hope this was helpful in understanding partial derivatives a little bit better and being a little more prepared for your next test.